Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will introduce parabolas. So parabolas are the graph of a quadratic equation. What makes an equation quadratic? Well, you know that if we have an equal sign, then it's an equation. What makes it a quadratic equation is this squared term. So y equals x squared is, if you like, the simplest quadratic equation. This here, y equals x plus 1 squared plus 1, is also a quadratic because of the x and the squared there. So the graph of this and the graph of this will both be a parabola. So what does a parabola look like? Well, let's start by graphing y equals x squared. What we're going to do is use a table of values and plot some points. So when you're using a table of values, you choose the x values and you find the y values by substituting each of these x values in one by one. So if y equals x squared and x equals -2, y equals -2 squared, which is positive 4. Now, when you're putting something like -2 squared on your calculator, make sure you use brackets, otherwise you'll get the wrong answer. So whenever you substitute a negative into a formula, use brackets. So if x equals -1, y is -1 squared, which is 1. Then 0 squared is 0, 1 squared is 1, and 2 squared equals 4. So we're going to plot each of these points. This is the point -2, 4, -1, 1, and so on. So -2, 4 occurs up here. -1, 1, 0, 0 is here at the origin, and we've got 1, 1, and 2, 4. So we've plotted these points, now we're just going to join them up. So this here is the graph of y equals x squared. This is a parabola. It's like a curved bowl kind of shape. All parabolas have that kind of shape. They're either going to look like this or they're going to look like that. Either going to be a smiley face or a frowny face. So we need to now identify the features of a parabola. So let's look at this parabola and its features. So the y-intercept of this parabola happens to be 0. So the y-intercept is just where the parabola hits the y-axis. It turns out for this parabola, the x-intercept is also 0. The x-intercept is where it hits the x-axis. So all parabolas have what we call a vertex or a turning point. So for this parabola we've just graphed, that's this point here. The parabola sort of goes down, it stops and turns around. That's why we call it a turning point. So the coordinates of this turning point here are 0, 0. So it's just a coincidence. It won't always be the case that the turning point is the same as the x-intercept and y-intercept. So it turns out parabolas always have an axis of symmetry, a vertical line that exactly cuts the parabola in two. Like this side is like a mirror image of this side. So it turns out that the axis of symmetry, the vertical line, always goes through the turning point. So for this particular parabola, the axis of symmetry is the y-axis. So the equation of the y-axis is x equals 0. So remember that vertical lines always have the equation x equals some number. In this case, it was x equals 0 because it hit the x-axis at 0. Won't always be the y-axis that's the axis of symmetry, but a parabola will always have an axis of symmetry, a vertex or turning point, and a y-intercept. As for x-intercepts, it depends on the parabola. Some have 0 x-intercepts, some have 1, and some have 2. All right, I'm going to rub out this information, and then we're going to graph this one. So pause and copy this down if you need. So let's now graph y equals x plus 1 squared plus 1. So we substitute each of our x values into this equation to find the y value. So if x is -2, y is -2 plus 1, -1 squared is 1, plus 1 is 2. Similarly, if x is -1, this will be -1 plus 1, 0 squared plus 1. And you can just use your calculator for this, and you will see we get this. So now we have some points to plot. Let's go ahead and plot them. So we start with negative 2, 2. So x is negative 2, y equals 2. It would be there. Now we do the same for all of these points. So notice for the last one, 2, 10, we can't fit on here, but that doesn't matter. What we can see is the parabola is again coming down, then it stops and turns around. So let's go ahead and join up these points. So here in green is the graph of y equals x plus 1 squared plus 1. So let's go through its features. So for the green graph, its y-intercept is clearly 2. So that's where it hits the y-axis. Parabolas always have a y-intercept. They don't always have an x-intercept. As you can see here, this one doesn't have an x-intercept. It doesn't ever hit the x-axis. But all parabolas do have a turning point. So the turning point of this parabola is here. It's coming down, stops, and turns around. So the turning point or vertex, they mean the same thing here, is -1 is the x-coordinate, 1 is the y-coordinate. So it also has an axis of symmetry, as do all parabolas. And the axis of symmetry is always a vertical line that goes through the turning point. So because this is a vertical line and it would go through -1 on the x-axis, its equation is x equals -1. X equals -1 is this vertical line here. It is a line of symmetry for the parabola. So hopefully what you can see here is that these two, the green and the black, are very similar graphs. The green graph is the same as the black graph, except we shifted it one across to the left and one up. And that's no coincidence. One across and one up because these two numbers were 1. It turns out, as you will see, this number inside the bracket shifts the parabola left or right, but it sort of goes in the opposite way that you'd expect. So because this is a positive, it actually went left 1. This number outside the brackets, it shifts the parabola up or down. So because it's a positive 1, we went, after going across 1, we went up 1. So this one works the way that you'd expect. Positive numbers shift it up, negative numbers shift it down. The number inside the bracket shifts left and right, but the opposite way you'd expect. If the number is positive, it shifts it left, and if it's negative, it would shift it to the right. So when we talk about shifting, we're really talking about moving the turning point. That's how you can look at it. So this one was shifted 1 to the left and 1 up. Turning point went from here, 1 to the left and 1 up. So we're using these table of values here now, but we won't continue to use them in subsequent lessons. There is an issue with table of values. Yes, they're easy to use, but they won't always tell us where the turning point is or where intercepts are. But we'll use them for now just to get a good understanding of the features of parabolas. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.